Okay, I got the clearance from Big Davo. Yeah. On the second version, this will be a still rough version of a Bridgehead 2-stroke, 2-cylinder motor / engine. That's right. Okay, this is a linear drive, obviously not a boxer. Okay, so you're looking at quartered triple V gates on a Dyson bar drive. Okay, it's a dual. Remember, it's also a dual cylinder, but we're talking about reducing the size of the cylinders, and this is linear cylinders, not reciprocal. Okay, that's right. So this is a completely linear motor, which spins on its axis, but the deal is it's completely linear. So anyway, you can see it right there. You'll see that on both ends. Now, like I said, this is a rough motor. We're not getting into the exhaust gas purge or anything like that. The next version on this one, which I will do, because this is the most important Bridgehead motor here, not the other one. The other one would be a slightly advanced lateral design. This one will be an actual advance, because you're going to start seeing these magnetic caterpillar drives and everything else. Now, this is not an Archimedes drive. That one I have not got to yet. Now, that part was for David. I'll get to that eventually. But actually, this version is just a beginner's Bridgehead of a more advanced version that I've got, that I'll be doing here shortly, which I've actually got part of it now. Anyway, moving along. We'll start at the top there. You can obviously see that. Think of this as a tube. Okay, the block is a tube. The crank is in the tube. Okay. Anyway, this is a rough version. I'm not getting into everything, but it's just showing you the basic theory and principle. Now, this is partially based off of my Dyson bar drive that I dropped, but that was for a vehicle. That's for magnetic, impeller, fractal field flux, etc. Now, remember, this isn't into the fractal stages yet, because you're not looking at fractal stator coils or carbon copper nano tubing, or nano, I guess you'd say it'd be stator coils, liquid stator coils. That's right, fractalized liquid stator coils. That's not any of this yet. This is just really mechanically basic. Okay, now, when you look at your V-gate there on the left-hand side, remember, it'll actually be 3. So the V-gate that you're looking at is quartered. There's 4 sections of that specific V-gate racetrack. Largest to smallest, largest to smallest, largest to smallest. Yeah, that's right, in a 360-degree circle. All right. Now, you're going to have 2 that are, the one you're looking at is on the vertical. Okay? As if you're looking down on it. Okay? It'll have 2 on the left and right-hand side pointed down. Anyway, the point is it'll act like a bearing. Okay? Believe it or not, it'll just be an electromagnetic bearing as well as an impeller, etc. Okay? Now, you can see the crankshaft. You got the horizontal pistons on either end. They're staggered 90 from each other. Or, I'm sorry, 180 from each other. That's okay. Just remember, it was a base design. Hell, you could have this to be a 4-cylinder, 4-stroke, 2-stroke. You could have all kinds of interesting stuff. Anyway, so what you're looking at is the horizontal pistons on the end of the crank. And remember that this would be a 360 degrees, but I put the blue drive mags on the end of the crank bars. The deal with this is I just did it quick. They're 90 degrees from each other, but actually they'd be less than that. It'd be probably 45s, all the way around the crankshaft and all the way around. That's right. Okay. The cylinder tube head, it's just a cylinder tube. It's no big deal. Your spark plugs and etc. Now, in the middle of there, you'll see the V-gate rails over the crank and the drives. Now remember, the V-gate rails will actually be staggered. They won't look all the same. They're standardized all the way across. They'll be staggered, probably by 45 degrees on each one. Okay, so just relax, and you can see the two pistons. Now, the pain in the ass is the linear circular pistons, the bar pistons. Okay, now if you'll notice, it'll be coming through the cylinder, this specific section on each end of the tube. They're going to be passing through the head, okay, and they should be set at an interesting angle. There'll be notches in the head there, okay, and as you can see, when it passes up, this will be on the right-hand side there where the arrow is pointing to it, the first arrow. The injector will be in the block to inject fuel in there. No big deal. This doesn't even have a carburetor or anything like that. I'll just put injector as in general. It'll pass it into the cylinder, and as the crank bar swings in, it'll detonate. Now, if you'll follow the arrow from that one over, you'll see that the piston on a side view is notched. That's correct. As it swings to the into the TDC, all right, swings into the TDC because it's riding in a groove. Think of it like that. The piston, the horizontal bar there, is swinging in a groove at both ends. The groove is your head, etc. It'll be ported to dump exhaust directly into the center of the tube where the drive mags are. Okay, now like I said, this is just a really rough design. It's not perfect. Timing will be interesting to get it to work right, but not that difficult because it'd be the standard magneto timing. Okay, that's right. No big deal at all. Okay, in fact, you could use your drive mags to do part of that with an actual internal magneto as the drive magnets pass through, or you can make the magnetos part of the tube itself. Okay, so you're getting part of that, and that's for fired your spark plug. That's your timing. The faster the crank spins, the faster the fire, and it sets your timing. Okay? Okay. As far as an actual timing gear, I don't think you should need one. If everything works out right, you can get your field collapse on the magnetos just right. Just right. Okay. Hell, you could have adjustable magnetos on the fly. Man, it ain't no big deal, baby. Ain't no big deal. Okay. You may or may not add flywheels in here. But, again, we've not got to the other more advanced version. Okay. So, anyway, this just shows you the principle. Now, right there, the notch in the piston, all right, the bell housing at the bottom of the notch of the piston, that little square right there, will act as, in a way, it'll act as a ring. Okay? It'll act as a ring as it passes through. In fact, you might be able to build a ring for it. Now, it's not square, obviously. It'd be round, or it could be square. It just depends on how the setup is. Okay? Since we're only talking a few thousandths of an inch, which I want to say the slop in them is like 2 thousandths in a compression ring. I don't remember on a two-stroke. Anyway, the point is, remember, it's a Bridgehead design. Okay, you got a lot of possibilities here. Anyway, so as it passes through, if you look at that little box, the notch is looking at you, but it would be actually passing from left to right in a circle. Left to right in a circle. Left to right in a circle. Okay, that notch is where, when it hits TDC, the compression will be just about right. Okay? Okay. Let's see here. And, of course, as the tube heats up, now, of course, that notch design will have to change somewhat. Okay? Because the injector would have to be directly on top of the piston entering. Okay? And then detonate. So you're not looking at compression near as much as you're looking at vaporization. Okay? We're not looking at high compression. because this is a linear motor, not a reciprocal. Things can change here. You could have a 2-stroke 2-cylinder with reciprocating on the crank. I was just trying to eliminate it and make it as simple as possible. Anyway, so that would need to be a slight redesign. It's no big deal. You could actually do compression from the top. Yes, you hadn't thought about this. What if the injector goes from the side, as you can see, you back up to the first box? What if the injector goes in, and right underneath that, the spark plug enters the chamber and is right, lined up with the notch as it passes through in the piston, and you make a mechanical compressor at the top of the piston. That's right, it actually enters the bore and compresses itself mechanically as you spin the crank, like with a starter clutch, a rope drive starter clutch, and the mechanical compressor actually pushes down where you can see the spark plug on the top there. What if you remove that and just put in that mechanical compressor, and it just pushed down, and as it pushes down, as the piston swings through, it compresses it, and you can detonate it with the spark plug relocated to the ends of the cylinder heads of the tube. Okay. All right. It's just a horizontal ditch piston. The piston does not reciprocate up and down. It spins and lines up with firing chamber. Initial inertia from pull start engages the Dyson drive. Remember that I'm using Dyson drive magnets on this for recombinated fractal fields, which will be dynamic and static. Engaging the inertia for piston to pass through horizontal chamber. Okay. Now, later at the bottom there, it said, later I'll get into more of it. Attempt exhaust gas purge from the firing chamber to vent through the revised Dyson disk drive, Tesla turbine and modification. It's not there yet, but it's an interesting design theory. Okay. Now, there'll be caterpillar drives, which I'm actually, that'd be neat as hell. I haven't gotten to that. I actually did that with a pistol. I never did finish the design on a pistol, but it was going to be a caterpillar recoil with no slide. Yeah, that's right. You'd have a semi-automatic 8-round 7.62 by 2.5 Tokarev, and the recoil would be handled with bearings and or caterpillars. I'm not going to explain it to you. Not external, be internal. The breech should be really weird, but it's an interesting design. So, anyway, this here, just don't know quite yet. Remember, I'm trying to keep it cheapest, easiest, fastest, and as much bang for the buck. Okay? And just general change up here. Okay, so anyway, there you go. I do not know if you're going to care about it. You shouldn't. You should be doing your own designs, because shortly, remember this is a Bridgehead design, shortly, and it won't be more than a year, possibly 2, at the outside edge, you should begin to see some serious tech push out the crap with the natural gas and oil-based stuff. The theories ought to be getting damn good. That way, like I said, the whole push for this is for your own power production, but without massive battery banks, which can actually, in fact, it can actually be done right now. I did the design years ago, but I never finished it, and I never implemented it. I forgot about it, which is an Edison battery in a 55-gallon drum. Okay, because in this case it was more about quickness and cheapness of design. Okay, to store power versus super efficiency. So you're doing a little bit of a trade-off. In this case, it'd be super cheap. Plastic barrels. Yeah, that's it. 55-gallon drums with liquid. That's all there is to that. An Edison battery. Go look it up. So what you would consider to be really crude is irrelevant because it's so really cheap for a home. Okay, Yes. All right. In this case, these Bridgehead designs aren't the end all and the be all. It's the next stages of it where when you buy a computer, it comes with its own automatic power supply. Correct. See, no more externalized anything. Your house, etc. And these would be simple enough that you could just keep doing it. Okay? And I'm not saying the design is good. I'm saying I'm trying on it. And look, for example, this would be designed for a weed eater. You'll laugh. You wouldn't have a motor on a weed eater. The handle itself would have the motor inside of it, because it doesn't have to be stacked large vertically or side to side. It can be lengthened to half the shaft being the actual motor. Yes, direct drive, you know what I mean? The only thing that would be external would be the recoil starter and the clutch. That's it, man. That's it. Think of that. Now, of course, this doesn't have any actual throttle stuff, so there would be some type of carb and, of course, your fuel tank. But actually, your fuel tank could actually become part of the shaft as well, behind it. Okay? So you're looking at very interesting, or to me, very interesting designs that are going to start coming out once people decide they're going to start doing Bridgehead motors, and then finally go ahead and push the advancement to the end. Just fuck all of this. It's a waste of time. Jump to the end. Jump to the end. You know what I mean? And to the end will be liquid motors. And that's what I've been pushing for quite some time. It's just I haven't got down to, because oh man, the sheer focus and investment of time. Because a lot of the problems that you have can be solved with better technology. Okay? At the same time, idle hands are the devil's work. So I got to make sure you people got something to do. So you got free power, but everybody still needs a job to have something to do. You know, what do you want to do? It would start allowing people to go, aha, I would like to do this. You know what I mean? Now I don't have to. I don't. What if your bills, none of your output is on any type of utility whatsoever? Short of water. What heating? All of this is taken care of right through here. This doesn't count my whole house heating and cooling with Stirling motors. I'm not done yet on that. Okay, that's going to take a little bit more effort. But once that design is done, that means housing will change and be a lot more super efficient than it is now. So there you go. You got a big problem. What do you spend your money on then? Well, if you've taken care of locomotion with these types of motors, and you've taken care of utilities, because these types of motors make your power production locally, that means you can take the utility companies and everybody and turn them into a backup, cut the crews, take those crews and make them into roving bands of motor fixers, man. Right? Yeah. And as this keeps going on, the prices and the production times will drop through the roof, because the design has to be simple. If the design is simple, and this goes for Mr. Tucker and his car, if the design is super simple, you're done. That means you can use extremely cheap parts in it, because you're actually getting to the part where you're going to be able to be extremely self-sufficient. All right? Right. So with these types of designs, you'll be able, coupled with housing, coupled with it, create a new service sector for the jobs. Money is whatever. It's just money. It's just fictional instrumentation passed back and forth. Take your pick. I don't care. It's as long as you can use it to get something, food. Because food would become your primary industry then. Now, wouldn't it? All right. That would allow you to spend more time. Let's say you're self-sufficient doing your own food. You wouldn't have to have a job per se. Okay? Correct. But some people will still be sitting and designing and making more efficient stuff. It would allow you more time at home to focus on more advancement if you so chose to do so. Most people wouldn't. They would just be junkies playing video games and kids on the internet talking smack when they don't know what the fuck they're talking about. The point is, there wouldn't be a university at that point, and part of the drive that I was doing was for the old-time symposiums. And I actually owe Ape Man 888 on that, who is American Face. Okay? I actually owe him on that because the old time symposiums are where your actual advancements are going to be at, and YouTube, believe it or not, plays a very, very large part, in technological changes and evolutions. Once people figure out what the fuck they can use YouTube for besides cat videos, man. Serious, nothing wrong with cat video, but there's only so much of that shit I can watch before I'm going, man, what the fuck? Alright? YouTube's not making anybody stupider. You are making yourself stupider. That's the point. You're not engaging your mind. But if you don't want to do it, that's fine. And if you want to make entertainment, that's fine too. I'm not going to pay any money for it. Look at this shit that I'm doing. This is cutting edge stuff. CMP Magnetics is using my stuff with fractal field recombinated magnetics. But yeah, I'm a fucking idiot, right? Well, I'm telling you here and now, once I get done with a treatise on fractal field static and dynamic units, that's going to be the end game for unsetting cellular material to a pleomorphic state. So you won't have to do stem cell research. You'll just take your genetic material, run it through a fractal field, unset it to a pleomorphic state, inject it to whatever part of the body you want, and it'll reset itself, and there you go. Yeah, there you go. It'll, man, we're talking some interesting stuff. It's way too far for me to get to right now because that's on the back burner. The most important thing would be this stuff here because the mechanics, it's always doing real fucking designs, man. I love Briggs and strap motors, but what the fuck? Plastic camshafts, Briggs? Are you serious? That's the best you can fucking do, dude. Really. 10 million motors strong, plastic fucking camshafts. You run it low on oil, one of these fucking 4-stroke motors, that's it, dude. It's gone. It's fucking, what the fuck is that? What the fuck is that, man? Old school fucking slop designs with these fucking companies. Okay? Slop efficiency. No efficiency. It's the service sector for it that you need to be worried about. But you're not fucking worried about that because you got to hammer out a goddamn paycheck, man. You got to make more. Not better, faster, more advanced. Anyway, so there you go, kids. This is a waste of fucking time, probably yours and mine. But I tried. Obviously, the ditch piston there's got to have some redesign, but it's a horizontal piston. It was just an idea. What the fuck is your idea? Seriously, what is your idea? Talk more, do less? Well, that's a common occurrence on YouTube. How about design more, talk some, or in my case, talk a lot, never say anything, but do more too. Yay for balance. Anyway, y'all take it easy.